Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see alcohol, phenols and ether in that first part, which is our alcohols. Okay, so this lesson is actually kind of a pretty good and a very interesting lesson. So as I said that this lesson comprises three different things. First is going to be alcohols, second is going to be phenols, third is going to be your ethers. Okay, so phenols and ethers are very small. In case like you are just giving them percentage wise, okay, if you are just segregating this chapter with respect to percentage, then alcohol can have around 60 to 65 percentage, that much we can give to alcohol. Phenols and then ethers will be around like 25, 30, 40, like I have segregated them based on 65 percentage, right? So that means 35 percentage to 40 percentage they could be. Okay, so that means alcohols is very important, and today we are going to discuss mainly about alcohols. So I think this lesson I'm going to segregate it into three different parts. First part is going to be alcohol, second part is going to be phenols, third part is going to be your ether. Okay, so we shall get started with it. So what is alcohol? Already we know some basic concepts based on alcohol. What is alcohol? Alcohol is an organic compound. Okay, and that organic compound contains OH. Okay, OH. That organic compound contains OH. That's it. Okay, any organic compound that contains OH group is known as alcohol. We can say it like this, right? Okay. So this alcohol can be segregated into some few classifications. There are a few classifications for alcohols. First is going to be based on your number of alcohols. Okay, so here you can see that there is mono alcohol, there is di-alcohol, there is tri-alcohol, and then there is polyalcohol. Your mono alcohol is where you are having only one alcohol in that entire organic compound itself. Okay, so this group is going to be what? It could be super primary or just primary. Okay, it could be super primary or just primary. This monoalcoholic, this compound is R. That means what? That means CH3, CH2, OH, then CH3, just OH, like this. Okay, this is your super primary, then this is your just primary. Okay, those people who don't know what is super primary and primary, please go and watch haloalkanes and then haloarenes. There I have explained what is super primary and then primary. The difference also is there. Okay, so next is an alcoholic compound which contains two OH groups. Okay, so what is that? It is going to be just R, so OH, OH like this, or also it can be RR, OH, OH. If in case the structure is like this, for an example, it can be CH2, OH, OH. Okay, it can be like this, or CH, OH, OH, 2. Okay, so or else it can be also like this. When both the alcoholic groups, both the OH, OH is being attached to the same carbon, then it is known as gem diol. Okay, then it is known as gem diol. That means this one can be said as gem methane diol, okay, or just methane diol, like that you can say, which is actually gem. Okay, see, for methane you should not use diol, to ethane you can use diol. Okay, so that means this is going to be like, wait, okay, like this, right? So that means what it is going to be, ethane 1,1 diol. So here you are having this 1,1, but if you want you can just take this 1,1 and then you can write here gem ethane diol. Okay, next is vicinal ethane diol. That is also you are having, okay, just vicinal diol. Okay, next is you are having trialcoholic, then you are having here polyalcoholic. In case of polyalcoholic, your number of OH should be more, like more than 3. Here it is still 3. After that it should be like 4, 5, 6, like that it can go. Okay, see, actually here is the place where I have to start, but I forgot because I wrote it like around half a week ago, and then here we are. Okay, see, actually in this chapter every topic like alcohol, phenols, and then ether, in that they'll be having all these. Okay, they'll be having their general introduction, then they'll be having their preparation method, then they'll be having properties, where properties are going to be two different types. One is going to be physical property, then another one is going to be chemical property. Okay, so these are the things we are going to cover. Now we are seeing introduction, then we are going to see preparation, then we are going to see physical properties, then we are going to see chemical properties. Okay, then coming to nomenclature. See, nomenclature is very basic thing. Like if in case you have studied it in our, if in case you have studied it in your class 11th, then here it is going to be very easy. And my English is very horrible today because after many days I'm talking in English, like around maybe 2 to 3 weeks probably. Okay, like it's not that much, but you know, when you're not in touch with the language, then automatically you will start to deteriorate. You will start to decompose that language. Okay, so that's why now it's kind of horrible. I hope I can pick it up again. Okay, I could pick it up again. Okay, so now we are here. That is common names and then IUPAC. See, nomenclature is actually of two different things that we know. It is like common names, then we are having here IUPAC. IUPAC is very easy. That is just your substituent group plus alkane plus ol. That means what? That means your CH3, CH2, CH2, CHOH, CH2OH. Okay, so that this is what? This is your butane. Okay, butane now. Okay, this is going to be your butanol. 1, 2, 3, 4. Okay, so this is going to be your butanol. If in case you are having here CH3 and then this becomes 1, and that means this is going to be methyl 2-methyl butane 1-ol. Perfect. Okay. Next is your common names. See, alkyl group plus alcohol. That means what? That means you just have this. Okay, for example, let us take that you are having this compound which is going to be propane 1-ol. Okay, so its common name is going to be propyl alcohol. Okay, propyl alcohol, that's it. Next is carbon containing OH. See, here you are having sp3 based classification and same thing which we had in our last chapter, right? That one we are having. Okay, so first is carbon containing alcohol means whether you are going to classify it as whether it is primary or secondary or tertiary or super primary. Very simple, right? You can just by looking you can say that this is primary, then just by looking you can say that it is secondary, then just by looking you can say that it is tertiary, and then just by looking you can say that it is super primary alcohol. Isn't it? Just by looking we can very easily say. So here what is it? It is just CH2OH. Here also it is CHOHC, COHC. Like this is actually all linear structures. These are all just your cyclic structures. Okay, so that means one more thing I have to say, that is, see, first I'll explain what is primary, secondary, tertiary. The main group is OH, okay, and in this OH is being attached to CH. Actually, already I've explained this in our previous lectures also, so that's why I did not explain it in the first place. Now I'm explaining it, and the video is not going well. Like I can feel it. I'm not explaining good. Okay, because for many days I did not take any lectures. Okay, so now you have to check how many connections does this carbon have. So you, just by looking you can say that this carbon has only one connection, that is with R. So if it is having only one connection, then it is known as primary. If in case this carbon is having two connections, then you can say it as secondary. If in case this carbon is having three connections, then you can say that it is tertiary. If in case this carbon is having no connection at all, like you can say that this carbon is not having any connection with any other group like this, okay, like R, so that means this is going to be super primary alcohol. That is just your methanol. Methanol is your super primary alcohol. Okay, super primary alcohol is going to be your methanol. Very poisonous. Okay, ethanol is the thing that people used to drink. Okay, used to drink. You are drinking now. That is your ethanol. This is your methanol. Okay, so this is your primary, secondary, then your tertiary alcohol mainly. But this is based on your cyclic structures. Okay, and you can, when you're checking it, you just check this carbon. Everything is sp3. Okay, every carbon over here is sp3 because they are having 4 sigma bonds. Okay, we all know that when a carbon is having 4 sigma bonds, then it is going to be sp3. When a carbon is having 3 sigma bonds, then it is known as sp2. Okay, so next, after this, what we are having is, we are having some structures. Okay, we are having some structures, and then we are having the same thing, that is your benzylic. Wait, like, I don't think people can understand this lecture without seeing a haloalkanes and haloarenes introduction. That's very important. Okay, now coming to allyl alcohol. What is your allyl alcohol? It is where I already explained this. Okay, this is your A. Here is one carbon, here is one carbon, here is one carbon. There are totally 3 carbons. Okay, so here you are having double bond, here you are having single bond, like this. Okay, wait. I'll just write the structure, then you will be able to understand. So this is what your structure is going to be. One carbon, one OH. So this carbon is having double bond with this carbon, then this carbon is having single bond with OH. Okay, one carbon, one carbon. Sorry, I said that there are 3 only. Correct. One carbon, one carbon, one carbon, and then this carbon is being connected to OH. Okay, so you can see that this is small finger, right? So that, what does it mean? That means this bond length, it is actually small. Double bond is kind of smaller than a single bond. Okay, so here you can see that this is smaller than this finger, so this is going to have double bond, this is going to have single bond, then this is going to be attached with OH group. Okay, that is what your allylic group is. A, how does A look like? A is like this now. Okay, then you are having your vinyl group. I already said that sp2 is inferior of sp3. That is your, you can just check here, this is going to be your CH2, CHOH. Only one thing that is different over here, that is here, okay, here one CH2 is extra. Once again. Okay, it is like this. Here you can see that one CH2 is extra, but here that CH2 is not available. Same thing is different. Okay, same thing as the difference between your benzylic and then your aryl. So here you can see that one CH2 is extra, and here that CH2 is not there. That's it. That's the difference between them. Okay, so your vinyl group is actually inferior of your allyl group, then your aryl group is inferior of your benzyl group. Okay, sp3 compounds are superior and sp2 compounds are inferior, and then this is your order. What is this order? This is your reactivity order. Okay, so by the way, this carbon is known as allylic carbon, this carbon is known as benzylic carbon, this carbon is known as vinylic carbon, this carbon is known as arylic carbon. Okay, so one example written here also. So this is what your positional order of their reactivity. That is, your benzylic carbon is highly reactive, then your allylic carbon, then your third position, okay, then your tertiary, then your secondary, then your primary, then CH3, then your vinyl, then your aryl. Okay, then carbinol system, yeah. This is a place where some people might get little bit confused. Okay, while answering, like, see, this is a very easy peasy lemon peasy topic, but while ticking the answer, you know, sometimes since we are doing everything very fast, so we might do some mistakes. By the way, there is no such word as fastly. Okay, fastly does not exist, fast only exists. Fastly doesn't exist. Okay. Okay, so carbinol system. So what is your carbinol system? First, what is your carbinol? Carbinol is where you are having here CH3 and then here you are having OH. Okay, your methanol. Carbinol is what? Your